Hey Edward, how are you doing?
Hey, how are you?
Good, good. So lately we've been getting a lot of questions about RDS optimizations. So jump into an episode where we talk about the RDS optimizations. We don't need to do like a talk about AWS every week, but this is something we get a lot of questions about that we are planning to do an episode about for quite some time now. So it's best to group those things together and then discuss them. So um, there are some gotchas in using RDS, especially the T instance types that we come across quite often that sometimes are hard to debug. Like we get a request, urgent request, the application is slow. What is happening now? Like CPU doesn't seem to be that high or whatever. And then whenever you dig in, it has multiple causes where the issues came from. So let's talk about some of them and how to avoid them and what they actually are, so people understand the consequences of using a T instances instead of another one. The price aside, but why it's generally only used in development, but in practice we see that a lot of people still use it in production as well. But it comes with some consequences, obviously. So without further ado, go ahead.
Yeah, so we're going to talk about RDS performance issues, but they also apply to EC2 because
Yeah,
an RDS is also an EC2. So a lot of the issues that you see with RDS performance, you will also have with EC2s. The reason why we're talking about RDS, I think, is because it's the first problem that starts appearing on an application when they have a higher load. So you have an application, you have your RDS, then you get more users. What is the first bottleneck? Often it's not the compute, it's actually the RDS. So the application starts going slow. What is happening? CPU is low on the application. RDS still seems to be doing its
exactly.
queries, but there's something is happening. This is what we often see. Um, like you said, T instance type is a special case. I will share some graphs right now. Um,
Oh yeah, please do.
just just to give you an idea where the performance bottlenecks are. So let's say that you are using a T1, T2, T3, T4, T4G. Those instances cannot burst to 100% all the time. And the graph that I'm showing is that there is a baseline. For the T3 large, the baseline is at 20%. You can always have 20% or less CPU usage without having any issue. But once you go over the baseline, then you are in the burst zone. And in the burst zone, you're going to have credits, and those credits are going to be deducted. It's like a bucket of credits. And the more that you are in the burst zone, the less credits you're going to have over time.
Absolutely.
When you reach zero, you can only have 20% in this case as maximum CPU usage. And that's when the trouble starts. So let's say you have suddenly more queries, so you have more CPU. Initially, that goes fine, but then after 30 minutes, 1 hour, 2 hours, when those credits run out, suddenly everything stops working because the RDS instance, or even the EC2 instance, because it can also happen in EC2, um, needs 40, 50% to be able to operate. And if it's just at 20%, it's just not enough to do anything meaningful. It just kind of stops working. It just gets overloaded and it doesn't answer any query anymore. And then it's like, okay, the application stops working.
It stays alive a
What
bit.
exactly? What is going on? Like a request takes like 60 seconds sometimes. Most requests time out. What is going on? And then you open your RDS console. You look at your metrics. And you're like, there's only 20% CPU usage.
It
This,
all looks fine. It's
that
okay.
looks fine. Yeah, yeah. But then actually, what happens is then you run out of credits. Now with T3, so in the past this was a much bigger problem, but now with T3 you can have T3 unlimited, or what is it called?
Yeah,
That
the
means
option.
yeah, you have the option to just pay for it. And now I think it's even on RDS it's default. Default, you pay for it. So you will not even see it. The downside is that, okay, you pay for it. So you pay more to be able to be in this burst zone. So if you're always paying, does it still make sense to be on a T-type instance? Maybe you should be on M5 and 6, M5 or M6 or M7 instance, or even a memory optimized instance. So then it might just not make sense anymore to be on those T instances.
No, absolutely.
That is actually the first thing that we see, recommend. But now that we are in the CPU category, what we recommend for RDS right now is not to run T3 large, not to run M5 or M6, but go to the Graviton instances. Because the Graviton instances, you don't see the difference. All the databases like Postgres, MySQL, MariaDB, they are also optimized to work on ARM64 architecture, which gives you better performance at a lower price. So it's kind of a no-brainer here to then just say, okay, I will use a T4 large instead of a T3 large. And also, you just get better performance. The Graviton, when you can be on a Graviton CPU, it kind of always makes sense if your application, your database can handle it.
Yeah, absolutely. Especially, like for applications on EC2 machines, it can be an issue, but for like RDS, like it's pre-compiled, you don't need to do anything for it. Actually, it's just an option to switch it. But it comes with a huge benefit. Like you said, it's more bang for the same buck, and even less buck, to put it that way. So it's cheaper and you get more performance. So it's like you said, it's actually a no-brainer, but a lot of people are still unfamiliar with it. I don't know if it's just marketing that, should be better or whatever, but it's just so much better to use those ones. It just works faster.
I think also with now that you have a MacBook with ARM64 architecture, naturally more people will go and deploy on that architecture because their development machine is already on this architecture.
Yeah, absolutely. The adoption rate there, like Microsoft also has some ARM64 laptops in the pipeline, and like our MacBooks, it's just the same. But it's like like for RDS, it's a no-brainer. For like EC2, when you're using those, I can see that people are still reluctant sometimes, but like it's just a lot cheaper. And the thing is, like it's you don't need to do anything for it to just get it cheaper. So that's always a good no-brainer basically.
Yeah, for RDS it's a no-brainer. For EC2 or Fargate or whatever you're using for compute, it's a little bit more difficult. But if you use something like Java that also supports ARM64, or you just need to compile on a different architecture, that's often pretty easy to get the better price. And also you have Fargate for ARM64, you have Lambda for ARM64. So now you have kind of all the compute platforms both have Intel and ARM architecture. So last thing I'm going to say about this CPU and T2 and T3 instance types is that Amazon actually has a page where it shows how many CPU credits you earn per hour, the maximum credit you can earn, the amount of CPUs you have, and then the baseline. So here, baseline for T2 medium 20%. So it kind of depends on also on the amount of CPUs, what the baseline is going to be. Now it shows here T2 large, actually 30% and not 20%. So here's 30%. So better to check what baseline you get depends on the instance type.
Yeah, but it's also important, like the difference between T2, T3, T4. Even there are some bigger differences. The newer, like it's just, like the higher the number, the better the performance will be as well, and the cheaper it will be, because like T2, like for example, is quite old, and T3.
Yeah, I don't think it's always cheaper anymore. So it used to be that the higher number is cheaper, but that's not the case anymore. But still, it's cheaper because you get better performance.
Yeah, absolutely.
That's how you have to look at it. But indeed, like because we're already working for so long with Amazon, we're like, okay, T2 is a main instance type that still people use. But actually, if you would start today, you would never use T2. you would straight away start with T3 or T4G or whatever is the highest instance family that you should be using. But T2 doesn't have this unlimited where you then can
No, it
just
doesn't have
pay
the
for the
option. Yeah.
yeah.
Then you
So, but
basically like you get a lot of CPU steal when you run out of credits. There's like nothing much you can do besides trying to get the like build up CPU credits again. But that's only possible whenever you are yeah, not like in an emergency situation where like there's a high demand on the CPU. Yeah, just but like I was saying, it's very important to make the correct decision here. And like, especially when you're still using T2 machines, you don't even have the option to switch to unlimited. And when you don't have the option and you run into an issue, there's nothing much you can do besides shutting down the application and like building up like credits again. But that's not something that should happen in like during an incident or whatever. And that's the cool thing about that unlimited option that you have, that you can like you say, default wise, just pay for it, or in other cases, enable it so it's able to go over that burst limit.
yeah,
Basically.
yeah. So definitely, if you are not aware of what your baseline is, you should go to this table in the AWS documentation. Have a look definitely to know what's actually the baseline, and can your RDS or your EC2 even work at this baseline? That's something that should be part of your performance testing before you go even live, right? That's often often we get the question like how many. So now we pick the instance type. So how many requests per second or minute or hour will I be able to serve? Well, nobody will be able to tell you. You just have to do the performance testing. You have to do load testing, and you have to see how is the application going to react when you have these requests. And if you leave it out, then sometimes you have surprises once you are in production.
Unfortunately.
But CPU is not the only issue that you can have.
No. And this one is
There's
even funnier to debug.
this is a little bit more difficult, but it's also going away. This particular one is going away because this is GP2 storage, which is the previous generation of storage. So now you can actually use GP3 storage, which doesn't have this problem of provisioned IOPS versus burst.
Yeah.
So we talked about CPU, and now we can talk about storage and IOPS and bandwidth and IOPS, because those are all things that you actually have to have a look at.
Absolutely.
So like I said, GP2 storage is the older generation of storage, so you can use GP3 storage now, but there's still so many databases, applications that are running on GP2 storage. So because it was there for so long, it's not easy to kind of just get rid of it and switch everything to GP3. There are a lot of databases still running on GP2. And what happens here is that you allocate a certain amount of gigabytes. So here's the volume size. So if you would assign 1 terabyte of volume, then you see that you are already at the provisioned IOPS is equal to the burst IOPS, so you don't really have that problem. So it's only for databases that have less than 1 terabyte of storage, because then you are, let's say you only provision 100, so you are going to be here somewhere. So you're going to get a lot less provisioned IOPS, but you can then burst to 3000 IOPS for a certain amount of time. And then here again, you have credits. These credits can run out. If the credits run out, you go to the provisioned IOPS. If it's only a couple of hundred of IOPS, it's probably not going to be enough to keep your database running. And that's also something that just makes your database almost freeze. Queries cannot be answered. It's super unusable. And then it's like application stops again. Application stops. What happened? Where is the bottleneck? And then you need first you go to look on the application. There's nothing wrong with the application. You look at the database, CPU usage, nothing is wrong. And then you need to look at the storage, like IOPS. Do we need more IOPS than we can actually it's actually provisioned? And if we cannot use our burst anymore, is that a problem? So this is also a little bit already a bit harder to debug, but the solution is actually easier. The solution that we always use is, well, we'll just then expand the volume, right? when you expand the volume, which is irreversible, unfortunately. So you will always have to pay more, but you expand the volume, you get more IOPS. I think even the when you expand, you will get a full credit again. So then you can even start bursting again if necessary.
Exactly. Also, maybe important to note is that this is unrelatable to the T-type instances. So this is also for every instance that whatever instance you are using, it's just if you attach a GP2 storage to it, RDS or EC2, it doesn't matter, but it's unrelated to that. So you can also come across this with non-T-type instances.
Indeed, that's true. So you can be on you can have like 16 CPUs,
Previous machine,
a lot of memory, but then GP2 storage and only 100 gigabyte provisions, and the application is still slow. And it's like, oh yeah, well,
yeah,
that
exactly.
happens. I also the benefit here is that storage doesn't cost that much. Definitely a lot less than CPU and memory. So the impact on costs to go from 100 gigabytes to 500 gigabytes just to get more IOPS is actually not that high. But today we are actually in a world of GP3 storage. And when this came out for RDS, I think it only came out like a year ago, beginning of 2023, GP3 storage like for RDS, because first it came out for EC2 and then only later it came out for RDS. This is actually what we already wanted for 10 years. Because why do we need to provision more storage to get more IOPS? That kind of doesn't make sense. Okay, it makes sense because that's how they designed it initially. It was, I'm sure this is much more difficult to design to have a system like this. But here, you get your baseline IOPS 3000 when you provision a GP3 storage. But then you can, even though you have, let's say, 100 gigabyte of storage, you can then go to a lot more IOPS just by paying for it. So separate from the volume size, you will just pay for the IOPS that you want. So you can just pay for 6,000, or I think 16,000 here is the maximum, 16,000 IOPS, even if you have a very small volume size. And this is what you actually need on RDS. If you have a data that is very hot, that is always changing, but you don't have a lot of data, then you can just buy more IOPS.
Yeah, the thing is, like, the majority of like people will not go to 1 terabyte immediately or whatever. Like they always have like this typical database. Like a terabyte is quite big already, right? Like for the majority of the applications. So in that sense, it's so good that you're now able to decouple it, because it's just performance predictability, especially for a database, super important.
Yeah, so it's really great indeed that you can provision IOPS independent from the storage. But also, you say, maybe someone will say, well, 1 terabyte isn't that much anymore. But then you might also have 10 databases, 20 databases.
Exactly.
If you run microservices, and microservices is something that we're going to talk about in our next episode or one of the next ones. If you have a microservice, let's say you have 20 microservices, you have 20 databases in QA, 20 databases in production. Now it actually becomes more important to make sure that those are efficient. So you don't want to provision 1 terabyte for every single of those 20 databases.
It depends, obviously, but the cloud bill will not be like something where you will be coming happy from.
Indeed, because we are talking about some people might also say, but why would you run T instance types? But then if you think about a monolith, okay, it's one database, one leaf machine. But when you think about microservices, if a company goes to microservice architecture, they start doing the microservice architecture, they end up with plenty of databases, and they don't want to pay so much money to get everything on a general purpose instance. And then they fall back on the T instance type, and then they fall back on very low IOPS provisioned, and then that's when you start getting issues. Then it's quite difficult to start debugging it, because you have so many databases and you have to kind of look where. First, you have to identify what is the database that needs something, that needs work.
But it's also the beautiful thing about it, because sometimes you have, like you said, some hotspots in the data set, even if they are distributed across multiple databases. And then you can just say, oh, this application, this part of the application is becoming more successful, more whatever, like there's more queries or whatever. And you can just easily increase only that size of that instance. While if it all was pulled into one instance, it would be like we have to upgrade it for one piece of the application. And you can just take smaller steps instead of like those big jumps in instance type. So if it's split, and then especially if you then attach GP3 storage to it, and then can just like, let's say it's all the data together is 1 TB, but it's split over 10 databases, 100 gig per database. And you can just say like, I'm going to give this database more IOPS, and it gives you more flexibility than always do those big increases. Not only architecturally that's important, but also like just super cost efficient.
Yeah. Yeah, one thing I want to say before we move on is actually that RDS also does striping. So RDS will provision multiple volumes so that you can have a higher IOPS. So this GP3 storage is just how it works in general, but RDS will even give you more IOPS because it can have multiple volumes, then share your data over these multiple volumes, and it does it all transparently. So this is also something that if you want to know exactly how many IOPS you can use on your RDS database, you should have a look in the documentation as well to see like how many IOPS do you actually get in RDS.
Okay, cool.
So one of the last issues that you can have with RDS or EC2, and this is maybe the most difficult to debug, is that even though you have CPU credits or no CPU credits, GP2, GP3, there is also a limited amount of bandwidth between the EC2 and the EBS storage. And that is not really reflected in a credit system. It's kind of, it is there in the metrics, but you don't really see that, it's not that obvious. So here you have the instance sizes. So this is just a table from the documentation. I took the T3 instance types. I'm showing here the T3 instance types, but all instance types have this. It just means that, yeah, it just means that you have a baseline bandwidth, you have a maximum bandwidth, baseline throughput, maximum throughput, baseline IOPS, maximum IOPS between the EC2 and the EBS volume. So EBS volume has IOPS and a throughput, but the link between the EC2 and the storage also have limits. In EC2, so also in RDS. So there is a possibility if you then go for GP3 and you say 16,000 IOPS, because that's what I need, 100 GB of storage or 200 GB of storage. But my instance size, I don't need a big instance size. I will just take an M6 large or something like that, or what we see here, T3 large. There's a maximum bandwidth, maximum IOPS that you can have here that is not sustainable 24 hours a day. So you can see here that the maximum IOPS for a T3 large is actually almost 16,000 IOPS. But this is the maximum. This is not a baseline. So for example, for the T3 large, these instances, and that's what they say here in this important message, these instances can support maximum performance for 30 minutes, at least every 24 hours, after which they will revert to their baseline performance. So that's not much. You will not be able to sustain 16,000 IOPS for a long time. You will need to go for a different instance type if you want to have a lot of IOPS. And this is also a limitation that a lot of our customers run into, right? They once they have more volume, once they have more traffic on their application, they said, I'm not going to use T3, I'm going to use GP3, but then you still have the bandwidth between your instance and the storage, and this can also be a limiting factor.
Absolutely.
And it's a little bit more difficult to debug.
Yeah. Even more.
Even more, yeah. So you went from easy to debug to a little bit more difficult to okay.
Yeah.
This is like now it's time to figure it out. Yeah, I think it's still visible definitely in the metrics. It just you kind of need to know that this exists, and once you know, you easily can figure it out.
That's the reason why we created this episode of the podcast, so
Exactly.
that we can make people aware of how they can debug and what the consequences are, or the not obvious things like the bandwidth here.
Yeah, I am sure there are also other limits besides the one that we mentioned. There's always kind of something like, for example, we had a customer, just to give you another example, and he was running lambdas. Okay, this is in compute, so he was running lambdas, and he provisioned a sub account with lower what's it called, concurrent requests, but just like the limit in ALS itself, which you can also choose. So there's also limits like your quotas that you can choose, or that you have to request. So these are also limits that you can run into. You can say, super simple example, I have one instance that has 8 vCPUs in Fargate, and I will scale when it's necessary. But the moment you want to scale, it says,
Yeah.
I cannot scale because there's a quota. Open a support ticket or change the quota and wait until AWS raises the quota. So there's definitely other limits that we haven't really touched, that are also in AWS, that you have to take into account, that can at some point limit your ability to scale. So you can scale very much, like you can scale very easily on cloud, but there are also a lot of limits there, like the limits we discussed today, and also quotas and other limits that you have to be aware of.
But those quotas are in most cases to protect you as well a bit. Like let's say if you had a default limit of Fargate services to 10,000, and it would actually scale to 10,000, like not every company would be able to afford it. So it does definitely make sense, but it's something you definitely need to be aware of, that those quotas exist as well. It's maybe something we can cover in another episode as well. They like to go over the obvious quotas, but something for in one of the next episodes then.
Yeah, I think first we're going to talk about microservices versus monoliths,
Yeah.
because it's more
Hot topic.
it's a hot topic, but also it's not necessarily that this has something to do with AWS. You have it on any cloud provider, even on-prem, that you can make this decision.
Absolutely, absolutely. So yeah, that's something I look forward to. I've worked a lot with them, and a lot of those have become from a monolith to a distributed monolith, basically. So that came with its own challenges, but more about that in the next episode. I think we can wrap up here. I think we
Yeah.
have the things that we wanted to share today. I hope everybody enjoyed it. If you have questions, leave it in the comments or let us know. We're always here to help out. Edward, thanks for your time.
Yeah. See you next time.
See you. Bye bye. Take
Bye.
care.